All right, page 311. Okay. So, number 2. Okay. Number 2 says, when copper metal is added to silver nitrate in solution, silver metal and copper 2 nitrate are produced. What mass of silver is produced from 100 grams of copper? Okay, so the first thing you need to do is write out the balancing. You need to write out an equation. Okay, so when you read it, okay, you may have to go back. Okay, so what is this saying? It says when copper metal, doesn't say which copper, just says Cu plus, okay, there's your silver nitrate. Is that compound balanced?
Yes.
Yes, it is. Okay? So then, like we said, it doesn't say which copper you have until maybe a little later on. It says silver metal and copper 2 nitrate are produced. So what is on the right-hand side of this equation? Okay? So we've got some copper nitrate and it says it's a single replacement reaction. Well, it doesn't say that, but you would presume that's what it is. So what's left over? Okay, so I think this is a way that different types of silver plating actually takes place with this type of a solution. So this would be an example of why this would possibly be important for a general or inorganic chemist, is to look through and say, okay, how much of a solution do I need to add? There's still something wrong with this problem.
Nitrate needs 2 minerate.
Yeah.
Why?
Because it's not copper 2.
Well, that still doesn't answer the question. Yeah, it's not balanced.
It's copper 2 and
It's copper 2 nitrate. Okay? So then this is a plus 2, minus 1, just like it was over here. So therefore, now I'm just presuming that we remember a lot of this from physical science. Do you like that little review, or just say this is what you do? Asking for input. You like the review? Okay. We'll do that sort of in the next problem. Because this, it didn't matter, because silver's by itself. This is what we said. We don't know which copper it is until we got to that side. But regardless, it's copper 2. Okay. Now, to help ourselves out, it says, okay, what mass of silver is produced from 100 grams of copper? So if we have 100 grams of this, how many grams of silver are we going to get out of there? Let's say, for instance, if you were this general chemist. I haven't looked at the answer yet, because I can cheat. I can look in the book. I'm going to say maybe a chemist is just going to say, I'm going to begin with 10 grams. It says 100, but let's say they start with 10 grams of this. Okay? So that's why I'm going to put a box of this around there. Okay? Or no, I'm sorry. They need 10 grams of this. That's what I meant. Okay? So let's say that's what their target is. Okay? Well, is 100 grams of copper going to result in 10 grams of silver? We don't know. So now I'm going to cheat and look at this. Oh yeah, there'll be plenty of that. Okay. You're actually going to make 339 grams. But let's say you needed to make 350 grams of this. But you just didn't start with enough of that. That's what means getting into limiting reactants. Because if you don't start with enough of one substance, you're just not going to produce enough of the other. Okay. How many steps is this? It's 4 steps. This would be 5 if you want to call the equation. But there's still one thing we got to do yet. Okay, you got a reaction, you need to balance it. Okay, you've got 2 nitrates over here and only 1 on this side. Okay, so we need to double this. Okay, and then therefore we need to double that. Is it balanced now?
Yes.
Yes, it is. Okay. Do you want to work on this together, or are you good on your own?
Together, please.
Asking for input.
Together.
Okay, so we've got 100 grams of copper. I just presume that you prefer that we talk as we go through? Would presume that. Okay, so 100 grams of copper. Okay, chances are every time you see something in grams, you're probably going to change it to what? Okay, so what is the atomic mass of copper? Okay. Now, every time you get 63.55 grams of this pure substance, you get exactly one what? Okay? All right. And if you like canceling out your factors, I mean, you don't have to do that. I just show that they're gone, and now you're in moles of copper. And from about what would you say, maybe a week before Thanksgiving, maybe. This next step is so important. Why? Because it's going to allow us to do what from this side of the equation?
Change it from copper into silver.
It's going to allow us to jump over to this side of the equation. Okay, so for every mole of copper, okay, what are we going to put in our next step? A mole of copper on the bottom, so they cancel. This step, again, allows us to change what we have, copper into silver. So, moles of what goes on top? Moles of silver. Okay? Then, we've got a balanced chemical reaction. What does that tell you need to do? Okay? Put a 2 here because of that 2. Okay?
That is the extra step.
Okay? I'm going to turn the volume down just a little bit. All right? Then, now we're in moles of silver, so what's our last step? For every mole of silver, how many grams do you get? 107, maybe? You will, it's not 109. It's not that we force you to do this, but how many are thinking, we're going to have a lot of this memorized by the end of the year, not because we were told to, it's just because of using it over and over. 0.09? That doesn't sound right. Okay. I was right the first time. Okay. So, from this side of the desk, probably one of the most common mistakes that's going to be made in that fourth step, take a guess what it might be. Okay? Well, we've got a mole here. There's a mole here, so I need to put a 2 here. Okay? Other than us telling you don't do that, how do you know not to put that 2 there?
Because it's already used.
Well, not only because it's already used, but what type of fraction is this? It's a molar mass. It's not a mole ratio like we see here. Okay. So therefore, when you multiply 100 times 2 times 107.87 divided by 63.55, you should get, this says 339.
That's what I got.
339.
Okay. Now, so that is what we come up with, 339 grams. Do you want to look at a problem from a different author,
Yes.
a different practice problem, or one in the section review possibly?
Section review.
Okay, so also on page 311 is practice problem or section review problem number 4. It says when sodium chloride reacts with, I'm sorry, I should back up. Rut row, are we good so far? Okay, second row, third row, See, at least some people get it, and it's kind of, at least do this rather than. Yeah, very good. Okay. It says, when sodium chloride reacts with silver nitrate, silver chloride precipitates. What mass of silver chloride is produced from 75 grams of silver nitrate? One thing I will say with this problem is the reaction pretty simple.
What goes on the right side?
Well, true, but I don't think there's any coefficients in here. You can use that to your advantage. Why is there no coefficients in here?
Oh, it's a double replacement.
Well, yeah, it's a double replacement, but has anything changed as far as charges go in the compounds? No, they're all the same. So you start with your problem. Okay. So what is sodium chloride? What's the formula? Okay. And that's reacting with what? Was it silver nitrate?
Yeah.
What is, well, it hasn't changed from this silver nitrate. So that's balanced, okay? Plus 1, minus 1, plus 1, minus 1. So we can presume that when we get to the side, what is sodium bonded with? The nitrate ion, that's right. And then what is silver bonded with? Do we need to change anything in our formula over here? We do not. So one of the things we see is if we're not changing anything because of the charges, why is this 3 over here if we said we didn't need to change anything? It's part of the ion, yes. This 3 has to go over there because it's part of the nitrate ion. So everything is balanced. It's 1, 1, 1, and 1. And we see what mass of silver chloride is produced from 75 grams of silver nitrate. Okay? 175 grams. How many grams of this are produced? Okay? No, that's not right. That substance. Okay? I'll just give you a few moments. Go ahead and work on that on your own. Hopefully, as you're watching this, yes?
Just out of my own curiosity. So if you had a mole of silver nitrate, it would go on the top, correct?
Here?
Yeah.
Yes.
Okay. That's fine.
Okay.
Like you had it.
So as we do this, we take 75 times 143. Okay. It says 63.3, but 63.30. Is that what we get?
Got 63.27.
Okay. Well, that's what this comes up with too, but once you round it up, there's 100. Okay. Do we feel proficient enough with this, or want to go over one more problem?
One more.
Okay. We can do that. And we'll take it out of a different author. Chapter 9 with this book too. Okay.
You just hear water rushing the whole entire place.
That's a nice stream. In the desert.
Is it underneath? It's like some things.
Okay, this would be, can I erase this?
Yes.
Okay? So this is what a separate problem from a different author says. So it's not that you need to write the problem down as long as you have the numbers. It says, what mass of ammonia can be made from 1,221 grams of hydrogen and excess nitrogen? Because that's how we word them problems. So what mass of ammonia will give you that? Okay, so here's ammonia. Okay, and it says when hydrogen reacts with excess ammonia. So, I said that wrong. When hydrogen reacts with excess nitrogen. That's what I meant to say. So, if this is what we know we form, it says hydrogen. Symbol for hydrogen.
H.
Okay? Reacts with excess nitrogen. Okay? And then we said this is what you're going to produce. All right?
Make sure you add the 2s for your gases.
Okay, but which one of them is gas? Both of them are. So this is diatomic. This one's diatomic. Okay? We've got a chemical reaction. Let's go ahead and balance this. Okay. This is odd. These are even. So you need to get this up to an even number. The only way to do that is what? Okay? But then upon doing so, 2 times 3 gives you what? How many do we have over here? 2. So how do we get this up to a 6? Okay? And what about your nitrogens?
Nitrogens are all good.
Nitrogens are good. So it says, what mass of ammonia can be created from 1,221 grams of hydrogen? 1,221 grams. How many grams of this can we make? Okay? So go ahead and proceed with that problem. Okay, so we'll go ahead and resume this. Now, you just see bits and pieces up here. But again, we are trying to prove a point here. I know we did it wrong. Okay? So, more often, I would say probably 8 times out of 10. And you might be the 2 times or 20%. What happens if you don't do that?
You might forget it somewhere else.
Okay? And where might that other place be? If you don't do it here either, if you just have hydrogen on there, why would you do that? Well, it's wrong because you want H2 there. Now, again, some of you are referring back to composition stoichiometry. That's different than this reaction type. So therefore, this is diatomic. We need 2.02 grams of this. Then for every mole of, H2. Okay? Yes?
Is that second column supposed to be flipped?
Ah, see? So easy to make a mistake. I did that to prove a point.
Okay. I just wanted to make sure.
I said it correctly, but I wrote it down incorrect. No, I made a mistake. I'm not going to try to say that. I was just seeing if you were paying it. No, I goofed there. Okay, so what else do we see we need to add to this?
4 ratio.
Okay, so how many moles of hydrogen do we have? How many moles of ammonia? Okay, so this is one of them instances where typically you just divide by a bottom number, but now since these are next to each other, you're going to divide by what, 6.06 at the end because of multiplying these. So 1221 times 2 times 17.04 is going to give you a fairly big number, but then remember 6.06 is on the bottom. Okay.
Why is the 3 on the bottom?
What 3 are we talking about?
Moles of hydrogen. Isn't that supposed, I thought it was supposed to be about.
No, because it's a mole to mole.
We're starting with grams of hydrogen, right? Okay, so that gram cancels out that one, right? For every mole of hydrogen, then this mole is canceled out by that. Okay?
Divide by 3 then, it's 20
So 6,867.
Yeah, about.
0.14 or something to that effect. Yes.
How'd you get 6.06?
Oh,
Because that's just how you do that.
Oh, I forgot.
well, okay.
It's usually we don't have.
Because usually when we've been doing these problems, okay, it doesn't happen very often, but typically what's happening is you're multiplying across the top and dividing by one number. But here we have 2 numbers next to each other. So if you were to multiply across here, you get a really big number, but I just wrote that over there for convenience sake, because 3 times 2.02 is 6.06. So that's where that number comes from. Okay? Now, this is a class that will weed people out in college. People say, I want to be a nurse. I want to be a dental hygienist. I want to go on to medical school. Think of Dr. Carson. What about him? Not just school, but especially in college. I wouldn't recommend this. When it came to his college chemistry class, did he go to lectures? No, he did not. He did not attend the lectures. He just studied out of the book. I would not suggest that. But should he not have passed chemistry, he would not have become a doctor. For those of you who've seen the gifted hands procedure, what did he invent for infants? Do you remember?
Is that the x-ray?
No. He invented ways to, let's say, operate on infants because their blood volume is just too low because they're an infant. They just don't have the same, 8 pints that humans have? Okay? So a baby might even have a third of that. Anytime you're going to operate on them, they're going to lose blood. But at that age, they're going to lose so much that they cannot survive. So what he had decided or figured out, stop their heart. Because if you stop the heart, it's not pumping blood. If it's not pumping blood, you cannot bleed out then. Okay? So sometimes success and failure in college can be something as, I'm not saying as simple as this, but we don't want that for you. Okay? We don't want you to be weeded out. Okay? So I know this is hard. It's supposed to be hard. Okay, so rut row, are we good? Second row. All of a sudden he gets quiet and he must be pointing at me. Third row.
Because I'm pretty sure my calculator's done.
Well, that was a nonverbal expression. That still works for some people out there. Okay, that's all I have. Well, I'm pause this for just a moment. We'll maybe do one problem, point you in the right direction here. Okay, if you want, we can pick one out to try to point you in the right direction. But I'm asking for input. Going once, going twice.
The first one?
Sold. You just said the first one. But we did that problem already.
Okay, can we do
Something very
numbers?
simple.
Can we do
No,
numbers?
no, we said the first one. Okay,
Dang it, Isaac.
but we said, okay, copper reacts with silver nitrate to produce copper 2 nitrate. We had that reaction up here through the process of single replacement. If 216 grams of silver are produced from the reaction, how many grams of silver nitrate are required? Okay, actually I think it's just similar. I don't think it's the same problem. Okay, So you're not, some of these you're given their reactions, like in number 5, number 3, number 7, and number 9. Some of these reactions, they just look like they're difficult, but they're not too bad. Okay, so copper reacts with silver nitrate. Okay. Okay, so what it had said was if 216 grams of silver are produced, okay, how many grams of silver nitrate are required? So I think in the previous question that we worked on together, you had grams of this to find grams of that. It's just the exact opposite. So you're starting with 216 grams of silver, and how many grams of silver nitrate are produced. So with this, one of the things that will happen is these will cancel each other out in that step, but you still should put that in there, okay? Because you have a 2 here and then a 2 there. Do you want any of that extra help, or are we good? Going once, going twice. So, all right. So you have time to work on these tomorrow. I'll catch up to you next time.